Well, good morning, everybody. Welcome. Thank you for coming to this session, Identifying Technology Capabilities that Meet Wildfire Science and Practitioner Requirements. To make sure that you're all in the right room. Let me share. Okay, you see my screen with the
yes.
Okay, the Kiko chat page, right?
Yes.
Okay. So if you, thank you for putting your name. Yeah, if you have not done so, please share your name and so on at the top of the page under attendance and check-in. And reminder about the participation guidelines. By participating in this session, you are agreeing to adhere to the ESIP community participation guidelines. The link is provided there. And if you haven't had a chance to read that yet, I've in bullet number 2 here, I've summarized the expected behaviors and responsibilities. And to report an issue, the link is provided for integrity counts in bullet 3. And of course, you can also report to any of the ESIP staff or the session organizers. The goal of this session, I think it's already pretty succinctly stated in the title. I'm just going to restate it here and generalize it from the session title to mapping end user requirements to potential technology solutions. So that's kind of a generic statement of that the title. And as a Gauda, we call that the consumption chain, where we start with the consumers or the end user, the stakeholder or the domain practitioners, or any of those terms, and work kind of backwards to what appropriate solutions, technology, data model appropriate to solve the problem. And if you look at the schedule, that's pretty much structured in that way, where we start with a couple of presentations by the end users from both the federal end of the spectrum from the U.S. Forest Service, as well as on the other end, the city of Boulder. And then the third speaker will start this mapping from requirements to technological solutions. And then we'll get into the more details in the breakouts following the presentations to further get into the mapping of requirements to solutions. Just to point out, in the resources for this session, the link there is to a poster that provides a big picture schematic of how this workshop relates to data science topics. And this will be also presented at tonight's research showcase. It should be presentation number 40 as of yesterday anyways. And the other presentation will be also available here after the workshop. And finally, and this is really important, there's 2 tables here under audience knowledge capture. Table 1 on the fire management needs and concepts, and table 2 on mapping the solutions. And we seated there some entries just to give you ideas of what it is that we're looking for. And these 2 tables will be input to the breakouts, as well as serve as worksheets during the breakout. So please, we invite you to enter at your ideas, your anything you can think of as you listen to the talks, or any ideas that come to you anytime during this workshop. Any questions so far?
So far, so good.
Okay, if not, I'm going to share my other here. Okay, are you seeing my screen with agriculture and climate cluster on top?
Yes.
Okay. So before we go to the talks, I thought it'd be good for those of you who are not familiar with the two clusters that co-sponsoring this workshop, the Agriculture and Climate Cluster and the Semantic Harmonization Cluster. So we'll just take a couple minutes each just to give you some background on why we're doing this, right? So what is Ag and Climate doing with wildfire? Well, the detailed story is kind of captured in this link here, which is in the thumbnail is to the right. It's kind of a concept map showing how we got to doing what we're doing right now with this session. But in brief, the Ag and Climate Cluster began in 2013. And for the next several years, we, among other groups, we work with quite a bit with the USDA Agricultural Research Service and the climate hubs, and the NOAA's Climate Resilience Toolkit, the CRT group, to generate candidate stories for their CRT case study repository. But in doing so, we also explore concept map as stories or telling stories via concept maps, as well as tracing provenance of climate adaptation decision to data, including a 2018 East of Lab project. In 2019 winter meeting, we sponsored a session on soil data integration challenges, after which in discussion with the disaster lifecycle cluster, we refocused that in the context of wildfires. And then last year, 2020, in both the winter and summer meeting, we had two sessions, both related to community concept mapping with the focus on the wildfires theme, as well as mapping data to decisions. And that's how we came to this session here today. And if you want to get more information, the most comprehensive location will be in our cluster wiki, the link here. And if you want to join us, we invite you to join us monthly meetings. The link here is the Google Doc containing all the agenda and notes from past meetings. And of course, the East Slack channel for Ag and Climate here. So now I'm going to ask Gary, if you want to do the same, provide a background on the Semantic Harmonization Cluster. Gary's the co-chair of that cluster.
Yes, thank you, Bill and Brian, for the invitation to this session and also working with us to prepare for it. As Bill said, I'm the co-chair of this cluster, along with Ruth Doer, who you will hear more about from during the breakout. I'm going to give an overview of what we're about in the cluster using this particular diagram, the Semantic Spectrum, which was sort of a visionary document as part of the Semantic Web Trust. As you see here, the simple depiction is usually going from the bottom where certain things have low semantics to them, such as just glossaries and thesaurus, to representations that have strong semantics, such as owl. And the vision was that we would move along this diagonal from where we were with relatively unsophisticated things to things that would now be ontologies and fully rich. Well, this vision is certainly relevant, but it's not complete. And we've learned along the way that you need to essentially leverage all of the resources that are along this diagonal, so that glossaries have meanings that people understand while computers can't, but they aren't often represented or may not be represented in a formalization. And you need to do that as you move along. And indeed, ontologies which don't represent meanings that people agree on are really not very useful. You also will see that recent efforts like knowledge graphs will leverage all kinds of things along this diagonal, from things that are out in RDF to actually controlled vocabularies and so forth. So the harmonization cluster is an attempt to sort of do exactly that, harmonize things along this diagonal, with the goal, of course, of making sure that the things that are represented in the ontology in OWL reflect the understandings that people agree on in the lower end on glossaries and controlled vocabularies and the like. As it says here in the bullets, we are working to develop and improve and disseminate community agreed upon best practices for doing just exactly that. And in particular, within the ESEP context, we're working with Suite and Envo, and particularly aligning these things so that they essentially are consistent with domain people's understanding. Let me go to the next slide, which shows, Bill, can you advance the slide? Yes. Oops, one too much. This slide summarizes sort of 5 principles here. One is that we recognize the importance of interoperability, and we're all about that. That's represented in FAIR, but if you make things interoperable, it also supports the easier goals of findability and reusability. The problem, however, along the diagonal I showed before, is that there are many competing vocabularies at the lower end and along the arrow. There's too little formalized agreements, and that's what we're trying to achieve here. We recognize that there's greater visibility about this problem, particularly within earth and environmental sciences, and we want to leverage that interest by actually showing how this can be done. We believe that semantic harmonization now is at a more mature level and actually has some tools that will help make it possible for other people to do this type of thing that we have been doing for a year or two now. And finally, we believe that ESIP represents a really good community of interest target to demonstrate best practices and proof of concept for this semantic harmonization effort. The last thing on the diagram is an example from the effort using some harmonized vocabularies that Ruth Doerr worked on. We have been incorporating some of those definitions into things like Suite and Envo. This is one particular example, so you have an idea about what the meaning of ice shelf might be and the axioms that support the definition of that. So some of it is geographic, that an ice shelf is partially surrounded by something, atmosphere in this case, some quality things such as buoyancy, that's floating, some things on process, such as formed by snowfall, but it also can be formed by mass ice movements, and then more geographical things, attachment to a coast and attachment to a marine body, both ends of what it is hanging out there. Okay, the last slide is just what a source diagram, such as Bill showed for his, so that there's lots of links. We have presented at the last 2 ESIP conferences, winter and summer, and you'll find information about those presentations as well as how to join us for that. Okay, let me turn it back to Bill now.
Thanks, Gary. Stop share. Okay. So before we go to the first presentation, let's do a quick poll, getting at everybody's wildfire experiences. So I'm going to turn to Brian to activate that now. Brian?
So if you, the audience, if you switch to your Slido tab on your Kiko chat screen, you will see the poll that's been activated. If you cannot find the Slido tab on your Kiko chat, look at your Zoom chat window. I've pasted the URL for the Slido poll there. And the poll is open. The poll question is, which of the following wildfire experiences apply to you? You can select multiple options. So we want to get a sense of what your association with wildfires is. And we'll let this go on for maybe 1 minute. Bill? We have 34 participants and 29 responses so far. Thank you, everybody. Okay, looks as if I hope you are seeing the results on your screens, but looks as if most of us have seen smoke or from a wildfire or seen the sky. For those of us living here in Washington, D.C., where I am, the sunset has been pretty for the past 1 or 2 days because of smoke from wildfires, by the way. Fortunately, none of you have lost a home to wildfires. 3%, a few of you have actually been evacuated from a home. And this surprises me, but 10% of responses says that you have actually fought a fire. But one of those would be, I know our speaker, Dave Zader, who has really been in the thick of things. And seen wildfires, about half of you have seen wildfires. Okay, thank you for that response. But hopefully this poll was to kind of situate everybody in what the upcoming speakers will talk about. Bill?
Yeah, and given the results of the poll, I think there should be some interesting inputs from the audience. Yeah, as we go forward. Thank you. So get back to this page here. So now we're going to start with our first speaker from the U.S. Forest Service. Everett Hinckley is the National Remote Sensing Program Manager for the Forest Service. He's going to be talking about the wildfire mapping, leveraging AI ML for needed improvements. So I'll hand that over to you now, Everett.
Thanks, Bill. I'll start my timer. And good morning, everyone. Yeah, wildfire mapping it's the main thing that I focus on in my job in the Forest Service. And I've been in this position for 12 years now as the National Remote Sensing Program Manager. And just recently, within the past year or so, there's been an increasing focus on the use of artificial intelligence and machine learning. And you can see my screen okay, Bill?
Yes.
Okay, thanks. I'm going to stop my video just so I don't distract myself. So when it comes to remote sensing is basically a toolbox. We need to understand what capabilities we have, where do we have information gaps, and how are we managing the data, both the inputs and the outputs. So we have data coming in, we produce products that are used by the incident commands, and the demand for, and we're always looking for improvements. The demand for fire imagery and products is increasing. So where does artificial intelligence and machine learning fit in? I'm just going to focus on one of the categories of remote sensing. One is conventional, non-time sensitive. The other one is time sensitive. Obviously, fire imagery is time sensitive. Fires move. Sometimes they move very rapidly, so the data is perishable. So the data is time sensitive. We use multispectral band thermal imagery or infrared imagery with pretty high fidelity and resolution for the tactical applications. We also use full motion video. That's less preferred by me. And all of this remote sensing thermal imagery is used for situational awareness, assessment, and decision support. And as I note there, there's no silver bullet solution. It's a toolbox. We use the best tools that we can employ. So there's a number of different things that we use that traditional systems that are a mix of tactical and strategic. We have manned aircraft that operate out of Boise. It's the National Infrared Operations or NIROPS group. We have one government-owned, government-operated aircraft, and we have 2 more on order. We are starting to use unmanned aircraft, and it's becoming more of a regular use. It's taken a long time to get to where we are with UAS or UAVs. We use several satellite systems, Motospheres, Landsat, et cetera. Those are primarily for strategic overlook of where the fire is. We use commercial satellites, Maxar and others. Ground observations, many of you are probably familiar with fire towers. That they're kind of an old-timey thing, but now they're coming more back into use. Some of them have automated scanning cameras on board, and we actually have used artificial intelligence and machine learning to detect smoke in those camera systems. There's a very extensive network in California where they're scanning the horizon looking for smoke. We also have contract aircraft and state partners that fly with us. And then we have our national systems, which are our classified assets. We have several programs, Firehawk, active fire mapping, which we've been doing for 25 years. The Hawkeye fire detection and reporting system, and FireGuard, which is a more recent program for near real-time rapid updates. And that's become a very, very important program in these really dynamic fires that we're seeing. So this is our single fire mapping aircraft now. We used to have a Citation jet, but it went out of service a year and a half ago. We have 2 on order. They have Phoenix line scanning systems on board that do the bulk of the fire mapping during the fire season. And like I mentioned, we are starting to use UAVs, not the big ones at the top, but the smaller platforms, which tend to be more useful. Although we do occasionally use some of the Predator-based aircraft on loan to us. This is what the imagery looks like. You get it's a panchromatic image. The hot pixel is turned red so that you know where the fire is. And you can also use multicolor interpretations of the image as well. But this is primarily what's used by the incident command to know where the intense heat is, where the hot spots are, where the flaming fronts are, and so forth. And this is what the fire product looks like. So this is an interpreted image. You have people sitting in front of screens drawing those lines and polygons, points, lines, and polygons. Heat perimeters, intense heat, scattered heat, and isolated heat sources. And this is what's delivered to the incident command along with you'll see a text box in the lower corner there. That's the information that's provided in addition to the map. And you can do 3D drapes on imagery to once you have the derived map. The Firehawk program, this is one of the classified systems where we're producing large-scale fire detection maps for the incident commands. It's designed to have the same look and feel as the products from the Near Ops program. It requires extensive person in the loop for the imagery analysis and product generation. So keep that in mind. Hawkeye is the fire detection and reporting system. This is basically automated and it provides near real-time wildfire alerts to federal, state, and local wildland fire agencies via the U.S. Forest Service. So this provides 15-minute updates. It's basically a thumbtack. We think we see a fire here. Here's the date and time, latitude, longitude, and a confidence factor. And these are pumped into our common operating pictures. So that system, the Hawkeye system, is basically, you turn the switch on and it runs. It doesn't require a person in the loop. The FireGuard system, the more recent system, this is one that provides somewhat coarse polygons, but good enough for the incident managers and the first responders, the people that have to call evacuation orders, so that they know where the fire is. And given these 15-minute slices, they can start to get an idea of the direction and speed of the fire front. And that's very important in the early phases of fire. This is a very manpower intensive process. We have National Guard that are doing the interpretation, and I would like to take the man out of the loop on this. So that's another area where we have a very manpower intensive process where I think artificial intelligence and machine learning can step in. And this is what the product looks like. You get these coarse polygons that are pumped out every 15 minutes, and you can start to see where the progression of the fire is going. This one happens to be pushing towards the southwest. You can see there's a scale bar there, 15 miles, and that's over the course of about an hour and a half, I would guess. So that fire is moving pretty fast. So where does artificial intelligence and machine learning fit in? Like I mentioned, the drawing of points, lines, and polygons on wildland fire operational maps, the national infrared operations maps that are produced by the aircraft collections, FireGuard, the rapid update products, and some of the commercial satellite fire products derived from thermal imagery. So we need to have GPS coordinates of heat detections displayed as GIS-ready polygons, lines, or points to map areas of new growth or spot fires since the previous image. The second area, besides just drawing the operational maps, is fire behavior models. And fire behavior models have been around for a long time, but the science behind them, the variables in them, you have terrain, you have weather, you have the fuels conditions, and all of these variables contribute to the fire behavior. Fire is also very complex. It's a complex physics problem. And I think that artificial intelligence and machine learning, looking retrospectively and forensically at fires where we have rapid time slices over fires, could improve the performance of fire predictive models in order to aid in wildfire behavior forecasting. And that's very important to the incident command teams. Is, you know, what do you expect this fire to do over the next 6, 12, and 24 hours? This would greatly increase their utility in fire and wildfire command teams and deployment of resources, personnel, engines, smoke jumpers, retardant drops, and so forth. That's the stuff that they're moving around like chess pieces during a fire, and they want to keep people out of harm's way. You're probably all familiar with the Yarnell Hill fire, which happened in Arizona a number of years ago, where we lost 18 firefighters in one fire in one day because they did not have the actionable intel to know that they were going into the wrong place at the wrong time. Another thing that we're looking at is the improving of the interoperability of sensor systems, sensor fusion, and the deconfliction of false alarms. False alarms is toxic to us. We don't want to be telling people that there's a fire out there that isn't, and we don't want to miss fires either. So having multiple sensor systems looking at the same piece of ground, being able to confer and validate that what they see is a fire and the other sensor says, I see that as well, that's really important. If you have a high false alarm rate, say anything over 5 or 7%, the people that are getting that data are not going to trust it. So looking ahead, artificial intelligence and machine learning, this is a topic that I've really been pushing at some of the meetings that I've been hosting over the past year. We want to continue to partner with Department of Energy, NASA, DHS, the JAIC, the Joint Artificial Intelligence Center, and a number of other people that are actively working artificial intelligence and machine learning. And we want to be able to develop collaborative solutions to the fire mapping piece, and then secondarily to the fire behavior piece. Our partnerships lead to success. We have really great interagency partnerships. We also have 2 working groups, the Tactical Fire Remote Sensing Advisory Committee and the Thermal Working Group. One works the unclassified side, one works the classified side. I'm the co-chair of both of those groups. And we want to be able to develop a clear understanding at all levels of management and leadership that remote sensing capabilities and derived products will continue to advance and be in demand. So we have to educate people about the products that we're building, understand what their needs and requirements are in order to be able to help fill some of those existing gaps or gaps that they may not even know that are there. And there's a lot of investment that goes on. It's not just budget. There's humans and button pushers. There's policy that we have to advance. We need to have champions. I like to consider myself a champion for this. And we need to have leadership at all levels of the Forest Service and the other land management agencies. And the safety of the public, our firefighters and agency employees is our #1 priority. So in summary, the demand for fire imagery is increasing. The increase in fire behavior that I've seen over the past 10 years is frightening. The trend is not good. You look at what's going on this year in particular, with the high temperatures that have been occurring out west, the lack of precipitation. These are really, really ugly trends, and they don't portend well for the future. As I said, remote sensing, there's no single source solution. You need to have a mix of resources and capabilities. We are looking more to UAS to help fill some of the gaps because they can be deployed at a moment's notice. And so the take home, the use of artificial intelligence and machine learning is perceived as critical by me and others to efficient and timely use of remotely sensed imagery from all sources. It's not a nicety, it's a necessity, because we have an increasing fire hose of data coming at us. We have to be able to manage that data, to utilize that data in a timely fashion, and to be able to pull out the critical information from those data sources. And I think that's my last slide, and I'm actually slightly ahead of schedule, so I will turn it back to Bill for questions. Let me put my camera back on.
Thank you, Everett. Really, really interesting stuff. We will have time, of course, in the breakouts to further, any kind of discussion and questions, but we do have a few minutes for a couple of quick ones, if anybody has them now.
I'm going to go ahead and stop sharing so I can get the full contingent of folks on the call here. Ah, there's Dave Jones.
Hey, Everett, how are you?
Good. How you doing?
It's great seeing you. I will slip in a question if I could. You talked about all the different assets that you're tracking and having to keep your awareness about. Is there any effort to make sure that those locations, that data for all of those assets are available so we can pull them into one map and share that out so we can kind of see that complex maneuvering going on? Is that possible yet?
We're moving in that direction, and I will say that there is some sensitivity to some of the data getting out to the public too early. We don't want to cause panic or people to be looking at maps saying, hey, my house is there, I need to get in there, and cause problems for the people that are managing the evacuations and so forth. So there's a lot of complexity to that, but we want people that can ingest data and produce useful derived products. We want people to have access to that data.
Good.
We also don't want them selling it back to us, but that's a conversation for another time.
Sure. Yeah. Great. Thank you.
Yeah. Thanks, Dave.
Sure.
Any other questions?
Well, this is Gary. I put in the chat, but I'll say it here too, that I think that the semantic harmonization process and machine learning AI work well together. They complement with each other. If your data is not harmonized, that's coming in for ML to work on, then you're not going to get good results out.
That's
so I see
right.
them as very complementary.
Yeah, and that's why we need to have folks that are invested and experienced in the area of artificial intelligence, machine learning, to be holding our hands as we're trying to move forward towards solutions, so that we understand what the art of the possible is, and they understand what it is that we're trying to do, and what our data looks like, what it needs to look like. Because my understanding is that there needs to be a lot of data going in the right formats and the right pieces in order to be able to develop those algorithms that lead us toward solutions.
Okay, I think we should move on. Try to stay on schedule here. And again, there'll be time in the breakouts to continue the discussion. Our second speaker is Dave Sater from, he was a retired from Wildfire administrator for the City of Boulder, Fire Department. He's going to be talking about wildfire management and planning by Polygon, a tool for improved decision making and resources usage. Dave, I'll hand that over to you now.
Dave, you're still muted.
There we go. Sorry about that. Thanks for having me, Bill. So I started this process of what I call planning by Polygon, which is kind of spurred into some other things, which is called pods now. But this, I'm kind of looking to automate this process a little bit more. So I kind of will run you through these slides to talk about how I'm an end user. I'm a due to the city being such a small agency, or the wildfire portion of our agency, I wore a lot of hats. So I was not only the planner, but I was also an operator as a division supervisor and air ops at the City of Boulder. And worked on the incident management teams for many years. So this system that I'm going to describe is something that I built originally as a paper-based product, and it has been used numerous times on Wildfire, so it's been tested and it's found to be very functional. And what we're looking to do is figure out a way to automate it. So the big problem with wildfire planning is it's currently a very manual process. It takes someone, hundreds or thousands of hours to plan out and find resolution, the detail for the tactical operations. And one of the goals is to try to eliminate a lot of that manual labor, because it's a barrier to people actually doing pre-fire planning. So if we can automate some of the more mundane processes and let us focus on some of the issues that require more thought, then I think more agencies will start to adopt better pre-fire planning. So one of the issues that came up during the Waldo Canyon fire was a lack of pre-fire planning. And after the NIST did their study, that was the #1 recommendation from them, that all agencies need to be doing better pre-fire planning. And due to the problem of it being such a manual task, it just doesn't happen. There's not a lot of agencies that have invested the time and effort in order to do better pre-fire planning. So just a little bit for you guys that aren't familiar with wildland firefighting, these are our priorities. So responder and public safety. So generally, these are sort of a list of priorities. Is first, we're going to evacuate the public and make sure they're safe. We want to contain fires at their smallest size. And then within that perimeter of that containment, we want to protect the values at risk within that. And then we want to control the fire's ability to escape that perimeter. So there's a long period of mopping up the fire and eventually extinguish the fire. And the way we go about this is called management by objective. And typically we start out with most firefighters when they are first on scene of a fire, they want to do what we call build a box. And then we're going to set objectives after we've done that, develop tasks and assign leadership and resources. And then we're going to, kind of work through our process. And that's can be a very time consuming process in order to get all the information that you need. So, and when I say build the box, essentially, no matter what size the fire is, there's always going to be some sort of box or polygon that will contain that fire. And depending on the severity of that fire, it may have to be very big, as in this example. We always jokingly say that all fires are contained. It just depends on what scale you're looking at. So if you're, want to look at like I-70 and I-80 and I-15 and I-25, that's a big box. So in order to do that, we need to find linear features. And linear features are essentially anything that we can hold the fire's progress against, or we can use as a defensible feature to fight fire from. And those can be like fire roads or trails, or even small, animal paths can be improved in order to create a defensible feature. Once we have to find these, and there are thousands of them out there, but very few of them are defined on maps. Typically, when we are looking for them, we start out with most likely a topographic map. And oftentimes these data sources can be very dated. So we tend to looking at the map, getting an idea, and then most often we have to go and scout for those maps or those features. And then once you've scouted for them, you have to kind of come up with a plan. So once you come up with an idea of where those features are, you have to do a lot of devising and coordinating. Then you have to implement that. You have to get people into the areas. You have to actually construct them. But the problem is all of that takes time. And it also takes a tremendous amount of mental energy. And typically, this is Maslow's hierarchy of needs. And typically, most firefighters are operating at a deficit where we're not having most of our needs met. Food, water, sometimes air can be a problem with depending on the smoke conditions. So trying to create a thought is very difficult. We also have a lot of distractions because we have a lot of task saturation. We're trying to oftentimes use text information rather than visual information. There's a lack of centralized info, so you're having to search for it, and we generally lack a common operating picture. So this is a typical Google map, and if I had one of these on every fire I went to, I would be ecstatic, but typically I get a very dated topographic map as my base map. And this is that same Google Earth image after we've done some pre-fire planning on it. This is in the city of Boulder, and this is using different polygons to try to delineate what types of resources we have, what types of linear features we have to fight fire from in forms of trails, you know, what trails are ready to fight fire from, what, you know, where the water sources are. So just a lot more information. So it decreases the amount of mental energy and task saturation that you have to accomplish during the initial stages of a fire by having all this information already on the map. And this is the reality, you know, this is the figure on the left is a map that I actually got on a fire, and the map on the right is what we had done, you know, for pre-fire planning. So oftentimes you get very bad maps. And this type of planning can actually be used for multiple events. It's not just for wildfire. This is actually, we used the exact same process during the 2013 floods in Colorado. So what is planning by Polygon? It's defining linear features for and using that visual data for making rapid decisions. And it's also a framework for planning and operations. So what defines the polygon? And the way I've described it is it's the smallest possible drivable perimeter that you can go around with a typical wildland fire engine. And the reason for that is I need a way to rapidly visualize what my most likely big box is. And I also need to be able to logistically support those operations. So that becomes the basic polygon. You can break these polygons up into smaller pieces using what I refer to as tactical opportunities, but this is the smallest definable, or what we're after as a definable unit for planning. So, and what's a tactical opportunity? That can be any linear feature that either bisects or injects into that polygon. So it could be a one-way in and out road. It could be trails or waterways or ridge lines. There's numerous different types of tactical opportunities, but they're just the opportunity to subdivide that unit into a smaller area. So if we look at the road networks, if we start looking at them, this is how we would define those initial planning units or polygons. And then our tactical opportunities are these one-way roads. And if we connect those, we can subdivide that polygon into smaller areas where we might be able to contain the fire at a smaller perimeter. So to kind of give it kind of a big scale, we can use the road networks as a way to start to divide the country up into regions, and then scale into areas, into zones, and then the units, those bright green units in there. Those are the smallest possible drivable perimeters within Boulder County and these different areas in the mountains to the west of Boulder. And so we can get into very fine scale planning units and really look at what it takes to control fire in those areas. We can look at the one-way in and out roads. Those also help us predict where values at risk might be. And this is the ideal, what I would like to see as a remote sense product is the edges of inorganic soils that we can use to fight fire from. That's how we fight fire. And then the other parts are injecting the data in there that we need to protect. So values at risk. We can also look at where our water sources are, potential defensible features, where drainages are, where ridge lines are, streams, large rock formations that we can tie together to contain fires, fuels layers. So it's just a framework for bringing in multiple layers of data. We can also look at fire sensitive areas, so that if we have areas that may have, like endangered species or or cultural areas, we can consult and make sure we don't destroy any of those while we're fighting the fire. We can look at our fire history maps. We can also do rapid wildfire modeling. This is a program called Wildfire out of UCSD, where they can give us a perimeter based on far sight in a very short amount of time, and give us, you know, a progression map out to 6 hours from the initial point. We can also look at resource mobilization of based on those polygons. How many resources do I need to protect the values at risk within that polygon? And when I take that rapid fire modeling, I can look and see how many resources I need to actually order versus what we do now, which is kind of like playing kickball. We show up and we sort of make a swag at how we're going to put our team together. If we can do a better job at mobilizing the correct resources and doing better front-end pre-planning, we can be more efficient and effective. So some of the other attributes or information or data that you could put into these polygons are, you know, vulnerable populations, values at risk, you know, fuels, fire history, where are you going to move people from these areas to, how are you going to access the area, different water sources. There's just, you know, it's just a framework for putting bite-sized amounts of data that we can consume in the field. And the more visual that data is, the more effective it is for us. This is actually just essentially an inventory that I created for the city of Boulder for our fire management plan. Essentially, it just goes through and gives almost every stakeholder an opportunity to add information or comments on what their concerns are within each polygon in order for us to have a better methodology for how we're going to fight fires within that polygon. And this is just a running list of information that I have kind of been collecting from different people as I interview people and say, what's important to you when you're fighting fires? And then essentially I did like a operations poll with a few groups of people, and there were some common themes. A lot of people wanted to know, and this came from our public information officers, where the perimeter of the fire was, having that as quickly as possible. And Everett mentioned how important that is. Knowing how close it is to a town or subdivision. We also wanted, you know, real-time imagery or overlays of the fire. And then one of the big issues that came up was there is no common place to gather all this data and display it in one place. So if we could have a way to aggregate all that data and lay it on a common map or common system. And then, you know, this is kind of the theme that came up, is that almost everyone wanted to know where the values at risk were in the roads and streams, and essentially defensible features or linear features where that we could fight fire from. Those were the two most requested items to show up on a map. So the goal is to automate the process to delineate linear features, and to make that as simple as possible so that there's less work involved and more adoption, so that it's a system. And not only do we need that system, but we need a system that is more standardized and common across, you know, all firefighting agencies. So I think I finished right on time about, and I'll leave it open for a few questions here.
Thanks, Dave.
So this is,
yeah, go ahead.
oh, sorry. So this is Ruth. So it seems to me that both of you guys are interested in polygons, one for planning and one for this is what's going on. And it seems to me that the intersection of those two things would be very useful to have kind of in real time. You know, here's our pre-planned stuff. Here's where all the you know, polygons and places we know about that you could fight from, underlaid or overlaid by, and here's where the fire is at this moment. Is that a correct assessment?
Yes, ma'am. That's exactly what we're looking for. And there are several situational awareness applications out there. I work on a program called ATAC, which is the Android Team Awareness Kit. And it does that. It's exactly what you're talking about. It's a real-time situational awareness application. The biggest limitation to it being operationalized is the ability to get data into the field, where people on the ground can actually use it.
And what is the biggest issue there? Is that a lot of that pre-planning information doesn't happen unless you happen to live in places like Boulder? Yeah, okay, I see you nodding.
Yeah, it's, I would say the city of Boulder is one of the most intensely pre-planned areas in the country. And part of that was, it was a passion project for me. I did a lot of it before it was even funded, because I tired of, to put it bluntly, getting my ass kicked by fire. I needed better information, and I needed it more timely, and I needed better mapping products. And it's exactly what Everett's after. We need better data, and we need it visual and not in a text format.
Yeah, this is Everett. I'll just add to that, Dave, that's what I've been trying to get people to understand, is that things need to be in a geospatial context, not in a video, not in tabular format or text. It needs to be something that you can see at a glance where things are relative to one another, and in the geospatial context is the best way to do that.
Yeah, and going back to that, Maslow's hierarchy, if it's not visual, it's not useful. It just doesn't work, because we just don't have the mental capacity to read something and apply it. We see this time and time again with burnover fatalities, where weather events are predicted. People read the weather in the morning, but they can't visualize it, and they rarely look at it later in the day, and it leads to tragedy.
I had a question. This is Dave Neufeld up in Lyons, Colorado. Was wondering about OpenStreetMap for linear feature extraction, and then also whether just and I'm not sure how good that would be as a data source for some of these topographic areas, but has there been any sort of volunteer-based efforts in some of these emergency situations where you bring in volunteers to help digitize some of that needed information?
I think the crowdsource opportunities are really incredible for this type of thing, because it can be done pre-fire. It doesn't, the worst thing to do is to try to do this during the fire. That's what we're doing right now, is trying to do this like a kickball team. We need to look at it like we're a professional organization, and we're gonna plan like we're actually gonna have a fire in these areas, because we do. It may not be this year, but eventually it happens. So how do we get to a place where we have all the data that we need? We're looking at it on a continuous basis. If there is an opportunity to automate some of this and remove the more menial manual labor of clicking along polygons, I think that would be very helpful, because it gives people a framework to start from. That's the most daunting task, is the actual creating of the polygons. It took me 3 or 4 months to create the polygons for Western Boulder County.
Yeah, I think all really, really interesting questions, and I think the discussion is really interesting. So again, we will be able to continue this in the breakout. So I think right now we should move on to the third and last presentation from Pierre Bourgi of the Helmholtz metadata collaboration. He's be talking to us about representing and aligning knowledge about wildfires, the need and challenge of semantic harmonization. Yeah.
Thanks, Bill. I'll need the screen to be freed before I can share mine. Apparently, the system lets me know. So, Dave, if you wouldn't mind, thank you. I will then share. Great. That should be visible now, right?
Yes.
Okay, great. Okay, thanks a lot. And indeed, so this is a crossover talk from the Semantic Harmonization Cluster. And we're very happy to be able to participate in this because, we hear the need for more machine-assisted or AI-ready ways of talking about entities that are being dealt with in the real world. And that's actually what our main activity is. There are a number of these resources, semantic resources that represent the meaning or knowledge about certain things in the world, be they wildfires, or as Gary said, we were working on the cryosphere before. And there are many out there. And if machines are going to start exchanging their data, but also the results of machine learning outcomes or polygons or abstraction layers, they're going to have to make sure they know what they're talking about the same thing. And they need to do that by brokering across some sort of independent knowledge layer, which I'll talk about a little here. So this is going to be a briefing on that, like what we do and what we'd like to start up. In fact, because our next focus for the Semantic Harmonization Cluster is going to be on environmental disasters and hazards, including wildfires, but also reaching out to other phenomena that are out there. So let's jump in. Okay, so we're good at representing information and data. We've been doing it for a very long time. We've been putting things out of our body extrasomatically, representing information and data. And then that gets processed in our brain. And then we use our knowledge to understand what it means. Sometimes we need training, we need culture, we need expertise to understand what it means in order to make use of it. And we've been doing this for a very long time. We've gotten a lot better at it over the years, to the degree that now it's so easy to transmit it. It doesn't cost very much because we have the infrastructures around. And then we tend to bombard everybody with information. In fact, our systems bombarded, transfer data, transfer information. There's a lot of it out there, but the idea in our head that's getting transferred is sort of stuck in our head while information is flying back and forth with papers, digital artifacts, etc. So, wouldn't it be nice if we could then make sure that what's in our head is as accurately represented as possible so that other people and their machines can also look at that conceptualization, look at that idea, and be sure that they either have data about the same thing or something slightly different. That way they know in advance if they're dealing with something that can be directly compared or if there's some kind of revision necessary. So that's the idea. We need to improve that. And indeed, that's what we try to do in our Semantic Technologies Committee through the various initiatives that we pull together using different technologies and different approaches. And then the Semantic Harmonization Cluster is trying to make sure that at least a few of those are aligned such that they can talk to each other without the user having to do much. You'll see a little bit more of that in the future. So this is a slide from Rob Raskin, who set up the suite ontology. And I think it makes the point really, really well. I don't think things have changed very much. We can represent a lot of things symbolically with data, with information. Again, you need specific knowledge to understand it. Sometimes they're just codification schemes, which maybe one system has and another one doesn't. We don't know whether that's good or bad. Sometimes abbreviations, sometimes grammatical structures can drastically change the outcomes of things or representation. Let's say that's a data structure. And synonymy and homonymy can also have similar effects. So it's a challenge. And when we get to environmental representation, things that are going on in the environment, things that we just take for granted, simple words are often very semantically heavy. So that's a forest, that's also a forest, even though it's planted. But as far as global definitions of forests go, from let's say the FAO definition, all of that's included. In fact, things that are included inside forest areas are very non-foresty-like things, including things like fire breaks, etc., that are out there. And a lot of these definitions that actually end up in our GIS systems, that end up in our planning systems, they have a lot of politics behind them. So, for example, the inclusion of rubberwood plantations is no accident, as there has been directed lobbying to make sure that that has happened in order for certain industries in certain countries to be able to map land as forests. Now that has a direct consequence, definitions matter. And if you have a different functional definition running your system, it's important to be able to point to that definition on the web from your system and say, we don't mean that because we're not concerned with that scenario. We're concerned now with things that are that flammable. I mean, of course, rubberwood burns pretty well. So there are lots of, there's conversations about things like that out there in the literature. And I'm sure that we'll face something similar in environmental hazards and disasters in different environments, in different nations, in different operational scenarios. You're going to have different operational definitions of very common words. And when it comes down to training ML agents to identify those things which we use words to label, the knowledge behind those words can be very, very different. And that's where the semantic technology stack comes in. In fact, it is one of the ideas inside the FAIR principles, the interoperability principle. When you dig into it a little bit, it says, you should be using a formal, accessible, shared, and broadly applicable language for knowledge representation. And that's exactly the whole idea, that machines need to be able to understand the knowledge that's behind the words and concepts we throw around very easily, which can be very different things in different scenarios. There are recommendations coming out on how to do that, and many of the semantic resources we handle inside our cluster and our committee follow those principles. And that's how it kind of relates. So artificial intelligence branches off into these two fields. Machine learning, we all know about that. And you have lots of data and somewhat consistent data, so you can train your agents to be able to identify features. And then the other branch is knowledge representation. Knowledge representation is that interoperability thing, and they go hand in hand. Sometimes you don't have the data, but you have lots of expert knowledge, which you'd like to translate to the machine layer in such a way that then you can align your data to it, even if it's not so much, not enough to train a machine learning model, or it's not consistent enough, but you're on the ground and you know what that thing is, and you can actually articulate that in such a way that a knowledge representation expert or an ontologist can put that into the systems, right? So that's how it fits into this whole, Gary showed that earlier, the semantic spectrum or semantic ladder. People shuffle around these aspects of it, but the general idea is that the more formal you get towards ontologies, the more machine readable that knowledge becomes. There's always a reason to choose one that's more advanced or one that's more simple. It's a cost benefit analysis that you have to do. And in semantic harmonization, we're trying to make sure that the ones that are there inside the kind of ESIP scenarios that we're targeting are mapped across the spectrum to one another. So that if an ontology is talking about a wildfire, then a vocabulary that's using that same word, they talk to each other, they point at each other. And that's how we're handling knowledge representation in order to help and boost AI outcomes. So why do we need it? I think I've made the point in words, but just to graphically visualize it, we may say the same word, have the same concept in general in our heads. And we'll say that word and it's close enough that we don't worry too much about the particulars. But the particulars can really matter out when you're creating data products and systems. So we want to externalize the knowledge the same way we externalize data and information in the text we write and the languages we speak. We want to be able to represent that knowledge directly into a machine system. So that's what we do with these knowledge representation artifacts. It's out there, it's on the web. And you can say, okay, this is exactly what I mean when I'm thinking of this word. And someone else can say, okay, I'm thinking something similar, but slightly different. And then iteratively, they can add to that graph, that representation, and be sure that everyone's views are represented as precisely as possible so that their systems then can share data, outcomes, ML outcomes, polygons more and more effectively. So just to borrow from the previous presentations, it's kind of like generating an AI-ready common operating picture for the machines semantically. So that's, I think, the link we're trying to build there. So what does it look like? So when we have a term and we identify a feature like a volcanic eruption, if you use a string, it's not such rich metadata, but if you point to something on the web that represents that thing in an ontology, you will then give the machine an anchor to say, okay, that's what we mean. It links out to other concepts, and those also have definitions that are machine readable and axiomatizable. So in a sense then, and that web link can be used across multiple systems to make sure that they're all talking about the same thing, because that's hosted outside of those systems. You don't have to map one system to another. You have a common knowledge layer between them. So yeah, picking up again from Dave's presentation, it's a kind of way of saying, this is how to make it visible on a machine level, right? So, we're getting closer to fires. There have been some cases in some of the ontologies that we use where we talk and we build some hierarchies for things like thermolysis, combustion, and there have been events and little use cases that have built some of these ontologies into that direction, linking it then to the cryosphere work that we've been doing. And we do have a small hierarchy. This is Simon Cox also asked for some things from the Australian services to put in things like bushfires and brush fires because they have a different lingo, a slightly different culture, but they're talking about or similar entities. We just have to make sure that they're the same kind of definitions so that we can map the terminology. So we already have a little starting point, which we will then be expanding in our cluster work as we go along. And indeed, we have some projects up there to help this along. Now I'm showing you Envo, but Envo isn't just, this is the one that I work with. But the whole point of the Semantic Harmonization Cluster is that it's not a one ontology show. There are many others. There's Suite, There are other projects that are creating similar representations that have a different usage scenario. And it's not enough to represent it in one, because you never know, is that project going to be live, active in that area? So we're trying to make sure that they're aligning as they develop, so that if you need to switch between them, you don't lose anything because they've already been pre-mapped. And that's really important, because as any solution, sometimes they can become idiosyncratic, and you don't want that to happen. So then it's a good way that we check and balance ourselves to make sure that another semantic resource understands what we're doing. We kind of agree on it, more or less. And so that's making the datascape a little healthier, and we're avoiding semantic silos, as we call them. And we're also trying to make sure that over time, as we dig deeper, we cross-check each other again, checks and balances, because over time you just get into the subject, and the meaning of the word that seemed so simple at the beginning drifts over time as you sort of layer and layer more interpretation on it. So again, you need an external partner, and that's the harmonization value, to make sure that this doesn't happen. So that's what we're doing, like with ESIP and Suite and Envo and a few other partners in different realms like Marine. We're trying to sustain alignment efforts between them to make that sort of layer healthier, so the user doesn't have to worry about it. But what we need is expert input, because we can have our opinions, we can look at various sources and write it. But that's what we experienced with the Cryo Hackathon and Ruth's surveying of 20 or more glossaries. That expert input really helps anchor the work that we do. So your knowledge about wildfires, what it actually looks like, basically cuts the fluff when it comes to our ontological fluffing, reasoning, thinking about it, ontological modeling, and says, this is what it really is. And then we try to model it. So it really helps that knowledge representation scape. So our cryosemantics work was based on that sort of logic. Ruth Duer's analysis of all of these glossaries, putting them together, and we looked at all of those definitions, or Ruth did rather, and we then helped and formalized it as much as we could, put it into Envo, push it into Suite, and we mapped the two together. We nano-credited everybody that participated, so all the expert knowledge is connected back to your ORCIDs, and again, anchor their ontologies and expert knowledge. So when we had a representational graph of things like permafrost, what it is, etc., with a human readable definition and machine readable links inside this representational artifact, we cross-linked that to Suite, and then on a code basis, this is what it looks like. You have that label, you have the crediting of who's been adding that knowledge, a normalized definition, some comments, links to the LTER vocabulary and the Suite ontology. So these two resources have been harmonized as far as we can get them harmonized. And we hope to do the same now with disasters and hazards, including wildfires. Right, it's tough to do. It took us a while to do that, but it was a lot of fun. We learned a lot of things about different kinds of frost and different kinds of snow, lambing snow, lots of icy things that I never really wanted to know about, but I do now. And I think it's worth it, because in other fields, like in biomedicine, once you build a resource like that, you can start creating, you can start using it not just as a way to store knowledge, but as a way to move data consistently and build products. This is the Monarch Initiative. It's a flagship project showing the use of ontologies to build knowledge graphs and move data consistently, and also interoperably, as anyone using those ontologies can link their data to the data inside the Monarch Initiative. So the architecture is pretty funky, but essentially it's using ontologies or knowledge representation technology to integrate data, because at least we know now that data is about the same sort of things, and using some tech to then create web services, browsing, analytical routines, etc. So once you're in that space, the so-called hard work is done, and you can start playing around with the data. So, it looks complicated, but it's certainly worth it. But it all begins with what we saw in the previous presentation. I was just grabbing some keywords. We already have things to start talking about and harmonizing our definitions and our knowledge about. This is a great place for us to start with a little bit of guidance from the Wildfire crowd. We can start to generate content in our ontologies and vocabularies and thesauri, normalize it to the expert knowledge, anchor it there, and then offer that back to the broader AI machine learning community to be able to use as tags on your GIS solutions, in your image analysis, video analysis, etc., that point to the web, that harmonize all those resources. So it's quite fun. And yeah, we're essentially thinking about how to marry the two once again, the knowledge layer with the data layer. So that's it. We hope that we can then grow that layer with input from this community, certainly the agricultural community and the wildfire community. And do be in touch with us. So Ruth and Gary are the contact points of Semantic Harmonization, and we're all very enthusiastic to start this work.
Thank you, Pierre. So I think, does anybody have like a really pressing question that they want to ask before we go into the breakout? Because I'm trying to stay on schedule here. If you have something you really want to ask Pierre right now, please do so.
Hey, Bill, just real quickly, I just wanted to say that this kind of work is so critical to helping all different types of decision makers and different use cases and different areas where this information has to come together and everybody's talking a slightly different language. I really applaud this effort. And as part of the disaster lifecycle cluster, we look forward to taking that hopefully to the next level where we can put that in front of actual decision makers. So thanks a lot for that. It's been a great series of presentations.
Yeah. So thanks, Dave. And just a note on those, many of these ontologies are also linked to United Nations ontologies that are getting closer to that, the things on vulnerability with the Sustainable Development Goals to link across the nations. So there is a policy angle that can be expanded upon too.
That's great. Thanks.
And once again, we will have shortly after this breakout, and we scheduled 60 minutes total with a 10-minute break in between, depending on the individual groups. So there should be plenty of time there to continue, to ask any questions and to continue the discussion. Before we do that, we have another poll that we'd like all of you to do related to values at risk within these polygons. So I'll hand it over to Brian to activate that poll now.
If you look back at your KikoChat tab under Slido, the poll has been activated. Essentially, it's a rank choice poll. You're given 5 things to rank what is most important to you, and that comes across important because as Dave had pointed out earlier in the conversation, different communities have prioritized these values at risk. Values at risk could mean anything from physical infrastructure to biodiversity reserves, and different communities rank these differently. And so as a fire manager, as a decision maker, it's very important for fire managers to have this kind of information, like given X number of things to save, what are your community's priorities? And so if you cannot find the link on the KikoChat Slido tab, look at your Zoom chat. There is a link to the Slido poll there. And so far we have 10 persons responding. And let's give it a bit of time because this poll is a little bit harder to complete. "15 responses. Yes, David. David commented perhaps add watershed as an option. That is correct. We should have done that. So David, in fact, this is my chance, and audience, this wasn't a planned question, but I'm just taking the chance to say that in response to David's suggestion that we add watershed as one of the values at risk, one of the breakout groups led by Ruth, Pierre, Gary Burke-Cross, and others. That's breakout group 1 largely on knowledge representation. Now that group will be working with Dave Zader. And so, like for example, David Neufeld, if watershed should be included as a value at risk, that group will be working on what do you define as values at risk and build out the knowledge map and the concept maps that will help AI and NLP, natural language processing systems, to figure out which are the relevant data sets that actually are relevant for values at risk, given that the term values at risk is large and somewhat smudgy. So just an advanced advertisement for the different breakout groups. Back to the responses for the poll, we are at 25 responses. Christina poses a very interesting question. Should this be relating to us as an individual or as we perceive our communities to rank this? Good question. I don't know the answer. Maybe Dave has a better sense of Christina's question. Whether the ranking is on an individual basis or whether the ranking is what the individual perceives the community to value. Dave? While we try to get Dave, I will offer this from another piece of work that I've been doing in the past. I did in the past with some Alaskan community villages at risk. So in those cases, we were looking at seeking community leaders within the community to convene small meetings within their community. And through these smaller meetings for those leaders, community leaders, to actually assess community-wide what they think. So it is a collaborative process, and there will be disagreements within the community. But Christina is right in pointing out that, of course, one single person cannot represent the community's interest. There needs to be a process.
Yeah, I think when we did the option for the poll, we were thinking more community rather than individual.
And Scotty, thanks for pointing out also that natural resources, which is extremely important, is not represented. And so, Scotty, like in the case of natural resources, timber, especially like in the Northwest where the current fires are going, of course, there are timber stands that have high economic value. So again, in the breakout corresponding to Pierre, Ruth, and Gary's group, we want to define those things, natural resources. And furthermore, again, kind of doing advertisement for that group at the expense of the time ticking on. At some point in time, what you want to do is to say, what are the, if you have a definition of the values at risk, the types of things, buildings, natural resources, watershed, what are the attributes that you might want to attach to those things so that an automated algorithm can calculate, say, some aggregate score according to those attributes that you attach to the things. So again, extremely hard, very complicated issue, but it's something for us to work on, ESIP-wide and that kind of thing. We're at 28 responses. What do you think, Bill? Should we close the thingy?
Yeah, I think we should move on.
Okay. So the summary is from your collective contributions, civil infrastructure has ranked #1 in terms of what you think you or your community will value if you are faced with a disaster, whether it be a wildfire or a flood or whatever. Biological resource, and I know Dave has an interesting story to tell about biological resource. We will not go into that, but for those in Dave's breakout session, if you want to, you can probe him on his funny story, not haha funny, but funny story about biological resource as a value of risk. Cultural resource and Native American allotments rank identical in coming next, and the value at risk, which is least essential, at least judged by this group, is viewshed. And Christina rightfully points out here that viewshed is highly ranked in Santa Barbara. And also, if you think about places like Martha's Vineyard, where you have extremely expensive property and people like to keep the viewshed clear of windmills for regenerable. Anyway, let's stop there. Bill?
Yeah, so we should move on to the breakouts. Let's see. Yeah, so we will have 2 groups, and one of them will remain in the main room, and another one will go off to the breakout room. So the one that's going to remain the main will be in the agenda, in the schedule, is the breakout group number 1, which is knowledge representation for wildfire planning and so on. And then the number 2, the technological solutions one, will go off into a separate breakout room. For the rest of the instruction, I'm going to hand it over to Bob to tell people to, what to do.
Yeah,
Bob?
great. Yeah, thanks, Phil. So as maybe you all have seen, I've opened exactly as Bill described the first, or the first breakout group is going to stay in this room, but then I've just opened the second breakout room, which is the technological solutions for wildfire planning and execution. And you should be able to self-select into this room if you want to go and discuss the technological solutions. At the bottom of your screen, you should see breakout rooms, and you should be able to choose that room, and then you'll get taken into that breakout room. Or if you'd like to stay in this room, just stay in the main room, and we'll be talking knowledge representation for wildlife planning and execution. If you can't figure out how to get into that other breakout room, if you would like to go, just give a little shout out in the chat, and I can also assign you into that space.
And a quick note to those who are interested in joining the knowledge representation and staying in this room, Pierre, I saw one of his slides. He's really collected a whole bunch of interesting concepts that he noted from both Dave and Everett's talk. And if you, I've also been listening actively and jotting down the concepts in table 1 that I noted. So for that group interested in knowledge representation, go with Pierre's list, and as a backup, you also have table 1 where it says concept. There are a couple of concepts that are noted down that Dave and Everett have pointed out. So with that, I guess we're ready to break up. Bill, instructions for breaks and when to come back and all that.
Well, yeah, just one thing on the schedule. So 1:10. So right now I have 12:22. So at 1:10 we will regroup all in the main room. But in this next 50 minutes or so, whenever the group wants to take a break, that's up to the individual groups, like 5-10 minutes, whatever. Okay. So we can all select ourselves into whichever room we want. Thanks, everyone.
Thanks, everyone. See you back here whenever.
Again, it looks like everybody's sort of self-selecting, which is great. But if you do have any trouble, just give a shout in the chat and I can shift you into the technological solutions group if you would like. But if not, you'll be staying in this main room for knowledge representation. So.
And for those that are here, we will be starting off by talking about polygons. Pierre, I actually I don't remember whether you were going to do live or whether I was going to do live C mapping. And
sure.
If so, do you want to show that?
Yeah, I'll share that. So what we'll do is we're going to interactively build a little mind map. It's very rough. This is what helps us sort of seed ontologies or seed some of our semantic harmonization work. And what we'd like to hear from you is more or less what should be in it. And as we talk about polygons, what are on their boundaries? What are the bona fide entities you use to bound them, etc. And this will help us begin our work. So I'll share in a moment. But Ruth, you can kick it off.
Okay, I captured quite a few concepts, and we do have the list in the notes already. So the concept of a polygon obviously is the first thing that probably should go on that list or go on the drawing. Polygon.
Yeah, so my understanding is that this is a very GIS specific thing. That's right, right? We're talking about a GIS,
yes.
a thing you draw, right?
Yep.
So we'll call it something like an information artifact, but we won't worry about the particulars, but okay. And I guess the interesting stuff starts with what it contains and what delimits it. But is there some subtlety about this polygon beyond that, like beyond the GIS thing with borders?
Well, yes. If we're talking about I personally think there's two kinds of polygons here. There's the Dave Zader polygons, and then there's which are really the pre-planning polygons. And then there's the polygons that are active fire polygons. So there's two different kinds, really.
Oh, okay, so I don't know how to process that. Would you, Dave? Would you like to, or others?
Yeah, I would say, well, there are almost innumerable numbers of polygons that you could make. So some could be past fire history, some could be a body of water. I mean, it's just any type of feature that is a shape, right? Or that is a bounded shape. So and Everett described it as points, lines, and polygons. So point is just a very small feature. A line might be a linear feature, and a polygon is a bounded feature. So, but a polygon, like a linear feature, could also be described as a polygon. So like in my example of looking at the driveway of someone's home, it's both a linear feature, right? And as well as being potentially a polygon because it has a width to that line. And the wider that width is, the more useful it is as a defensible feature for fighting wildland fires. Does that help?
Yeah, so that's interesting because that's where like the sort of representational world overlaps with the so-called real one. So for example, if we have like, as you said, a driveway or a road, lines and polygons, it's not fair to say that it is a polygon or it is a line, but both of those could potentially overlap basically with the physical thing. Yeah. And then it depends on the resolution of your plotting or detection, whether it is that or not. So I think that's kind of the relationship we would create with driveways, bodies of water, other stuff, basically.
Yeah, I mean,
the line is two-dimensional.
In GIS solutions, you'd say it's a two-dimensional?
Because it's not a straight line. It's very rare that lines are straight in the real world.
So I'm hesitant about that because again, even a curve is still considered one-dimensional, but in GIS solutions, that's
points and lines should be what? Points and lines.
I guess dimensionality is not the differentiator.
Okay, so use the phrase linear feature, even though it isn't a line, linear feature as a concept.
Mm-hmm. So okay, well, we can say this is some have width.
So, sorry, I'm wondering though, if once we get into topography, wouldn't these become 3D?
We could, for sure.
Yeah.
So that's when you get to topographical landforms. But this, this is useful because essentially we're having this mapping of these different entities. And this would be a topographical topography.
The basic difference between a line and a polygon is a polygon has area. The line is a line.
Mm-hmm. Yeah, so that sticks with the one-dimensional idea. But okay, but that's good with the topography because then we have the spatial entity. So I think like, Dave and others, you were talking about like what these things overlap. And we have here essentially a list of features. That's where things like the values at risk and stuff will emerge. This is the spatial abstraction part of it. And then they have this overlapping thing, or they can be bounded by, right? So overlaps or is bounds, overlaps. So what else would you like to capture in these polygons? Like what's the key for your work to be able to capture in those polygons?
So, to try to give it a concept, it's, I want to be able to drive a vehicle, and typically I just use a, 4x4, wildland engine as the definition of how I might be able to drive around it. And not only does it need to be able to support a vehicle, it also needs to be able to be used as a defensible feature for fighting fire from. So obviously, like, a 6-lane highway would be awesome, but that rarely exists in most of the places we fight fires. So a road that has a component of inorganic material. So, just soil, without any organic material in it that can burn across that line. And then at the smallest possible level, because once the fire starts within that polygon, I want to try to find the easiest way to contain it at its smallest, area or perimeter. And then within that polygon, you're going to have other linear features. It could be a trail.
I hate to say this, but I think you're going way faster than we can map.
Sorry.
I think you need to slow down a little bit.
Yep, no problem.
And what I see might be in the middle of this that's not represented here is the feature or feature of interest you keep using. The polygon represents that, and then there are the instances of these features, such as rows. The idea of a feature or a feature of interest and various types of features seems like it might be important.
Yeah, that's a good way to describe it, a feature of interest.
Okay, so I found it really interesting that you have this very clear operational definition. I need to drive my 4x4 through this thing, otherwise I can't make this line. And that's in terms of training ML models and aligning that to KR models, that's like really key. It's sort of saying this is what makes it real. It's not an abstraction. I need to get there, right? So that's what I'm putting a note on that too. Cool. So so you're saying these
all
areas
define the containment of the fire. So you have the bounding is not the definition of the fire, it's the definition of the containment.
Yeah.
The polygon is the fire.
Well, wait a minute. There's two different kinds of polygons, and I think we're talking about the planning ones with Dave. So in other words, these are the planning polygons that are used to do your fire pre-planning, whereas the other polygons are, I think, being talked about in the other room.
Yeah,
But,
and that's kind of what I meant is there, a polygon is just a, like you said, a feature with an area versus just a line running down a map. And scale is important in that, like if I'm just looking at a very large, overview map, those polygons could look like just a linear feature or it could look just like a line. It's just a question of scale. That's how you're looking at it. But it's important for us to also know the width of those features, not just that there's a feature there. It could be, oftentimes like I'll look for a fence line because I know the cows walk along the edge of the fence. And because they walk along the edge of the fence, they trample the vegetation down there. And there's typically a little bit of inorganic material there that I can use to potentially fight the fire from. Like I can light fire along that feature and allow the fire to grow away from that feature to create a wider fire break.
Can I ask about the planning tool? If you're what happens when you combine two polygons? Say that is there a way to create a super polygon that would be a super planning area?
Yeah, I mean, and that's kind of where I talked about like using our road networks to create, regions and zones and areas, so that you can, I like to describe it as how do you eat an elephant, one little bite at a time, so that when you're trying to tackle planning of these areas, it's not so overwhelming to people. So if you can give like if I said at the city of Boulder, I need to plan all of Western Boulder County as our, kind of our zone, how do I break that up into giving little pieces of that problem to different people within the county so that we can use some of that crowdsource opportunity, like, hey, you work on these 2 units, I'll work on these 2 units, so we can break it into smaller bite-sized chunks. And the other benefit to that is when we try to send that data over limited bandwidth networks, we're only pushing the data out that they need, not a lot, not a huge piece of data. Because the bigger the areas become, the more unlikely it is to get that data to people in the field.
So we have to represent the hierarchy of polygons. There are polygons within polygons here.
Yeah, and I just think of them as different layers of data.
So just to let you know, I have to disappear for a moment. My dog apparently needs a break. So I'll be right back. Sorry.
I just wonder if the weather condition should be also included somewhere here.
Well, that's an interesting part. So things like the contextualization of the polygon. So I suppose you don't have polygons for, let's say, weather systems. That's more a question of an attribute of the polygon, like it's contextual data. Is that how it works?
I mean, you could overlay the weather over top of these polygons. I mean, just think of it as like layers of like, you know, I need to go back this far. I'm dating myself, but we used to use acetate to, you know, create these layers of data, and you would stack those layers on top of each other to get the information you needed. So it's the same idea, is that you're just taking multiple layers. It could be, you know, the fire history, that's one layer of acetate, right? And then we take the road network and overlay that on top, you know, over that. And then we take fire weather, and we can see what the weather is doing across all those layers, so we can look at, okay, what's the effect going to be within this specific polygon where fire is burning. Like the National Weather Service has fire weather zones, so you could look at that very gross sized polygon and look at what your weather might be in general terms within the polygon that you're operating.
Dave, what's fire weather?
So fire weather. So the National Weather Service has specific forecasts for, not like, you know, you look at your general forecast like on the news. They have very specific forecasts for fire weather. It includes things like, you know, stability of the atmosphere, you know, relative humidity. Obviously, you see that a lot of times in your general forecast, but it's all the very specific components to what we need for information in order to predict fire spread. Okay.
I have another question. Okay, when you gentlemen all get very good talks, but I'm a little bit surprised. Okay, you did not mention about the smoke. Of course, apparently, like the case you are assuming the fires are already there, so you are kind of try to handle that. But how about even say, well, some smoke condition somewhere, and then even can prevent this fire to getting worse. So I'm not sure if those things need to be included here as well.
So I'm back, but again, I'd like to remind everybody that currently we're talking about fire pre-planning, which is Dave's planning polygons. Dave, do you have I mean, you apparently have called your system of polygon planning something in particular. Maybe we should use that name here instead of Dave's planning polygons. What do you call it?
It's Dave's polygons. We can call it, you know.
Yeah, and if polygons gets confusing, you know, they're just units that we're creating. It's the polygon describes a unit, you know, and it's just an area that you're defining and using as something that is both a containment feature for fire that you may use to contain it, and you may end up subdividing that using those tactical opportunities, which might be like a trail running across that polygon from one side of the road to the other, or you may have a one-way road that just, you know, interjects into that polygon, and you have two of those, and maybe you're going to cut fire line, like physically, you know, dig up down to mineral soil from one feature to another in order to create a fire break that you can fight fire from. So we make, you know, we have constructed fire breaks, we have natural fire breaks, we have, you know, man-made fire breaks like roads. So there are different types of lines out there that we will want to know about what is out there. You know, a stream, a dry riverbed, you know, the top of a ridge line is an important feature to us, because as fire goes up a ridge, it tends to slow down at the top of the ridge. So oftentimes that's one of the places where we'll construct fire line, because the potential for it to cross that fire line is much lower. So there are all kinds of features out there that we want to be able to identify.
Cool, and I think he's trying to capture that right at the moment. And again, you're talking pretty fast, faster
That's
than we
fine. I
can
mean,
type.
we don't need to get all of it, but it's like getting the general idea, because what that tells us is that, you have these features of interest, and then you have another kind of hierarchy where they can play a particular role in the wildfire management scenario. And one of those roles, key roles, is that they can serve as fire breaks, right? So what other kind of like key roles are on your mind? So some things are fire breaks. I guess some things actually promote the spread of a fire. I think I saw like fuel sources or something.
Yeah,
that's what
fuel models would be a whole nother layer of information out there. So we have there are 13 standard wildland fire fuel categories that we use. There are 47, I forget this, there's another set of fuel models that we use for research, which are Scott and Bergman models. I can look that number up if you need it. But essentially that's the way we use what we use for general categories of fuel, so that we can plug those into our fire models and get a spread rate prediction.
Okay, so that's another sort of interesting phenomenon. So this is the spread of fire. That's a process, right? And that can have a rate. But that's really interesting, that fuel sources story. And when you say something like that, there are 13 standard fuel sources. This is the stuff that sort of makes my heart aflutter, right? Because that's, for an oncologist, this is a fantastic thing to hear.
Yeah.
If we can get our hands on that as a terms of that anchor for semantic harmonization, that's really, really key for us.
Yeah. And those are, they're a general category, and oftentimes the only way to, and that's one of the issues with fire modeling or fire prediction is the fuel categories. They're a generalization of what fuels are in that area, but they're not exactly what is in that area. They could be have deeper depth. They could have more components. The current land fire data is essentially on a 100 meter by 100 meter square, and they give each one of those squares a fuel model number. But within that area, it may be vastly different from 1 meter to another. So it's just a generalized category of what's the predominant fuel is inside of that.
There's also the different types of forest that Pierre brought up in some of his photographs, and that's related to fuel type, that are very important in determining what's going to spread. And then there are the soils. If you have organic soils, deep organic soils that hold moisture versus mostly mineral soils, where I think that's where you often construct the fire breaks. But there are so many variables, and yeah, this is the type of thing that really interests me, being a plant scientist. So there you go.
Yeah, it's very difficult to the micro scale at which fire of all the inputs of what affects fire is pretty fantastic. There are just hundreds and hundreds of different factors to think about or look at. And we do, in our fire models, don't use all those features. They use only a few factors to look at what fire potential is, and that's why we have such a difficulty predicting the spread of fire.
Yeah, that's really great also, because this gives us something in that layer, this quality of flammability. So for the machine representation, we can say, okay, all of these fuel sources, and also the fire breaks, all of these things, they have some sort of flammability quality. And then in your data layers in the different systems, you can then add data to that, like a coding system of how flammable these things are, or the risk factor associated with them, etc. And that could be,
and there's a very seasonality to them, and We have what we call 1 hour fuels, 10-hour fuels, 100-hour fuels, 1,000-hour fuels, 10,000-hour fuels, depending on their size class. And a 1 hour fuel, which is something like grass, it can go through its entire range of fuel moisture within 1 hour. So, it could have been rained on in the morning and then you get some sun on it and it can dry out within that 1 hour period essentially and become flammable again. Whereas something like, a big heavy log is going to be more, seasonal. If it's a dry season, then that fuel will become more flammable. If it's a wet season, it will be less flammable. But it doesn't change as quickly. So there's so many little micro factors, and we use 1 hour through 10,000-hour fuels and looking at our fuel modeling as far as how the fire will spread and what fuels will actually be consumed. Will they be consumed just on the surface, or will they burn down to complete white ash?
Right. And I also would like to, about the weather. So I think the wind speed, definitely strength is also very critical.
Yep.
Right.
Yeah, we usually refer to it. Fuels, weather, and topography are the three primary factors.
Right.
And topography has a bunch of, not just the fact of the slope, but what direction does it face? How much solar radiation does it receive throughout the day and at what time?
Right. And definitely the heat wave is different. That's one very often. You probably the fire itself is already caused by the heat, right? The temperature, weather.
Yeah, correct.
This is Rama. Sorry to have joined a little late, but I was wondering if you're also going to be including the assets of value to be saved during a fire. I don't know if.
Oh, that's the second part of the conversation. And
okay. Okay, sorry.
Right.
I missed that. Yeah.
So if we can kind of get a little further along on this part, then we can switch over to that.
I'm putting on my GIS hat here, and I want to make the polygons and lines a central skeleton. Maybe correct me if I'm wrong, but fire breaks are lines and fuel sources are polygons. If you can align this with topology and GIS, I think that's the way that Dave's been thinking about this. There's a reason to recreate that.
I guess you could say fire breaks have spatial extent and fuel sources have spatial extent. They're different extents.
Right, there you go.
I was wondering, for the main people, does the idea of a map play a role within this diagram to organize certain things? You want to represent these things as part of planning in a map, in layers of a map.
Yeah, I mean, a map is essential. I think that, and that's, the key piece to this is how do we create these, these features or polygons for what we're going to consider as our primary containment area for each, piece of the landscape. And that's ultimately what my major goal is to try to reduce the amount of manual labor it takes to define those, or to automate that process. And then also looking at all the other linear features that may cross, or the lines that or other polygons within that planning unit, in order to define, what are the values at risk inside of there, what are, what types of resources are we going to put in there? And there's a lot of manual data that's going to be required to be entered for each one of these planning units or polygons. So, how do we make this process easier to do for people rather than the, multi-month process or multi-year process that it takes to actually do this?
Let me ask a question of Dave. When you're working in City of Boulder, you're working alongside other city planners, and they might have a GIS as well. can you identify which of these concepts are shared concepts that they would use as well? And which ones do you really need just for your Dave's planning polygons, the fire application?
I mean, there's a lot of data that's available to inject into these or to create layers. And that's exactly what I did. I went into our catalog of GIS data and searched, and basically browsed through them and found things that I thought would be valuable to firefighters, like, where are all the fire hydrants located? Where are the, streams, the data that did exist. The thing that didn't exist is the taking the road network and creating those individual polygons where it was the smallest possible, drivable surface around. And I tried to get our GIS folks to build something like that, but they didn't seem to have the ability to automate that process.
I mean, I think that's again the application scenario of these semantic technologies, because other systems, people will have different GIS solutions, and sometimes they can't change it. They're stuck with it for quite a long time. It's mandated by whichever authority they report to. And so in a sense, if they're stuck with that, but they're still labeling the same kinds of things, bodies of water, road types or so, that's where these sort of knowledge representations can broker between what you're using on a planning scenario. At least you know that their systems are delimiting the same sorts of things. It would make it that much easier for you to sort of there would have to be a conversion step, but it would make it that much easier to port over your planning polygons onto their maps and vice versa.
Yeah, and one of the things that, there are like categories of road types, they're like, you have highways, you have state roads, you have state highways, you have local roads, you have driveways, and those all have sort of attributes to them, in their width or how they're constructed, what their design standard is. Like a state highway has like 2 fog lines running down the center or on the edge of it, and a double yellow line of some format running down the center, and it has like sort of a prescribed width that it has to be in order to meet that standard. So some of those things can be helpful for defining features or the width of them or their quality, if that makes sense.
Yeah, absolutely. And indeed, that's what we would capture, because in the US, those things are defined a certain way, and of course in different countries another way. And again, if we have those representations, we can be a bit clearer about what those limits are. I think there was something about forest mapping early days with GIS. I think I heard this at ESIP. I can't remember where, but like the biggest forest in the US was actually just a green strip on a very long highway, and it just met the criteria. So that was like the biggest forest they could find in that state. So yeah, we have to be careful with that.
Island?
I don't know. But it's just like, this is where things can get kind of slippery, and where again those definitions matter, right? Because that's where the domain knowledge matters, because the ML routine it satisfies all the criteria, so it will label it as such, but you need that intervening expert knowledge to say no, that's not right, So that's kind of cool to capture. What are the most difficult things to capture? Like when you're expressing these, let's say the abstractions that you're talking about here, like the fire breaks, what's a tricky thing to communicate to somebody else in terms of a kind of fire break or a kind of fuel source that for most domain, if you're not in the domain, it's really hard to understand what you mean?
I think fire in general is just difficult to communicate. It just, and I will use a recent political event where someone, one of our state representatives said that, wildland firefighting was an unskilled job, and it's an extraordinarily complex job. There's just so many like nuances to it. I came from a structural firefighting background, and I when I first started wildland fire, I felt like that was absolutely true. Like I was like, oh, wildland fire is no big deal. It's just, go out, spray it out, go home. And I thought structural firefighting was complex until I really got into this field, and I discovered that this is, the most complex thing I've ever done. And that's what's fascinating.
I think you mentioned that in your talk, this wildfire behavior. You used that, this keyword here. What is that? Like, could you give some examples of this?
Oh, it's just, how how high are the flames? How fast are they going to move? Essentially it's, describing the fire spread. That's the fire behavior.
Okay.
And there's other components like spotting, roll out, where fuels will roll down the hill and start new fires down below. Spotting will start fires out in front of it or to the side of it. There's just, there's some people spend their whole career just working on fire behavior prediction, fire behavior analysts.
But that's really cool because this sort of lingo, it's similar to like when people build ontologies for the military, because there's an operational language being used. It's that much easier to actually detect what in documents or in data sources or so what's going on, and that is not widely known. So getting that into knowledge representation layers is of high value. These kind of these terms you're mentioning here. So
Dave, sorry, Dave, can I have a question about the fire history? You have very sophisticated plan. You have seen so many fires, but I believe you also do the analysis about the cause of your fire in Boulder, right? Is any okay? Well, the thing like the human cost, especially you got.
Are you?
I mean, the causes of fire, right? And I think you should have done analysis on all kinds of reasons cause for the fires. And I'm just curious about even those by humans say, well, someone smoking and caused the fire, whatever.
Oh yeah, cause a fire. So yeah, actually, I spent quite a bit of time gathering data on where we had potential fire ignition sources. And the number one, smoking is probably not one of the biggest causes of it. And Boulder, one of our main causes of wildfires is, one is lightning. Two is, or probably the most common cause is transient campers. Like our homeless population and transient population that come through and are sleeping in the woods. Those people tend to create warming fires or cooking fires, and oftentimes those are our most common sources of ignitions.
And that's very, I mean, again, that goes exactly to the sort of UN SDG sort of scenario, because that indeed is a vulnerable population and tied to like societal development. So again, enable like doing interventions to enable them to have appropriate equipment or training or better housing, that'd be nice.
Yeah.
Indeed could be a way to actually reduce the costs of wildfire. So those linkages are extremely important on a policy level to understand how to if that's one of the major causes, well, one of the interventions is not more necessarily post-event intervention, but it's to prevent it, right? Which means preventing the need for that. So that's really important, actually.
Yeah, and another big cause of wildfires in our area is down power lines, and I think that's true in wind events. California has certainly seen that, and there's a tremendous amount of work being done to try to figure out a way to prevent those fires from occurring.
Mm-hmm. Well, that's great. Mm-hmm.
Thanks, that's very good. Thank you.
There's also the idea of how you have access to fires. It's not all driving into fires, although that's a very important tool. There are also smoke jumpers and people who are ground crews who aren't necessarily in vehicles, and also dropping retardant from airplanes and stuff like that. So that's more in the control than the prediction part of it, though.
Yeah, and I mean, these things are all interrelated. So the same information that someone drives to the fire and someone that is aerial delivered to the fire are the same types of information. Both groups want the same info at a certain level. If you're driving there, obviously the road network is critical to you. If you're flying in or being parachuted in, you also want to know where open open areas are in terrain, or open, or even more so, open areas that are, don't have, large rocks in them, that are
Right.
soil. So if you could map those as well, so landing zones, and I was an aerial delivered firefighter. I worked at a smoke jumper base, and I worked also on a helicopter. So mapping out those types of features are also very important. When it comes to retardant, you look at the ability to deliver the most retardant, or the longest line length with the amount of retardant that you have. So oftentimes we are looking for ridge lines that have less fuel on them. So we'll want to use, so we can essentially spread that retardant farther. And the other benefit to that is when fire burns through light fuels into retardant, typically it will either go out or be very easy to mop up the fire in those areas. And when I say mop up, I mean put out every single thing that's on fire within a given distance of that fire containment feature. So a lot of times they'll say, like 1 or 2 chains or 3 chains or 100 feet, there'll be a number attached to that mop up standard. So we need to, be able to not only contain the fire in that area, but also get into that area and be able to put it out. So if we drop retardant through heavy timber and there's, a lot of duff, or, the organic materials have built up to great depths, or there's lots of dead and down fuels in there, that can be very difficult to mop up, as well as we may have a lot of overhead hazards from, partially burned trees, which we call snags, or stuff that's going to fall over on us. So the best case scenario for us is to try to fight fires from areas where we have less fuel, so we don't have to put people into those areas for extended amounts of time, because we typically have more injuries and fatalities during mop up than we do during the actual containment phase of the fire.
Oh, those are important insights. Thank you. It's really interesting.
Seems to me in this context, electrical transmission towers and transmission lines play an important role, both from the point of view of being obstacles for aerial drops, as well as being sources of fire.
Yes, absolutely. Yeah, and I describe those as a, as a linear feature. Right of ways is a good way to, capture a lot of that. Because you may have, an electrical line. So typically underneath those power lines is going to be reduced amounts of fuels. So they can also be good places to place fire line on the edges of those features.
That's cool. So what would you call those? So I guess those are tactical opportunities.
Yeah, because and the reason why I call it a tactical opportunity is, a road I can pull up and support almost immediately. It's like how we're going to access it there, and if I can drive all the way around it, that's the simplest way for me to deliver firefighters, or even better, water. But if I have something where I can't drive to it, I've got to get people to it. I have to feed them. I have to get equipment to them. I may need to put hose into those areas in order to help hold the fire. So it's not as easy a place to fight fire from. And that's why I wanted to use the smallest perimeter of an area that you could drive around as our defining or our definition for what is that planning unit or polygon.
I see that we're running up to our deadline of 1:10. Maybe we have a few minutes to talk about values at risk. I hear you talking as part of the planning, the idea of vulnerability, which values at risk are vulnerable. So maybe we could have a little bit of thought on that.
Or Ruth, isn't that coming later? Or
Believe it or not, we're using our time up much faster than we were thinking.
Yeah, there is no part 2.
Yeah.
Oh, there isn't. Oh, I see. Okay, because anyway, just as well, because I'm fading. I'm post second vaccination and I'm having strange reactions. That's why I'm a bit slower than usual. Okay.
So Ruth, is there time to discuss values at risk and vulnerability?
I think we should at least do a little bit on values at risk, maybe in a different part of the diagram, or we can connect them up later.
Sure.
We had a starter list, I believe, in the oh, I can't find them in the list. There's
You can start rattling them off.
Okay.
Just before we do that, when we say values, now those are that's shorthand for the things that are valued. Is that correct?
Yeah, things we care about.
Okay, that's exactly what I mean. Things that we care about that can burn, basically. I think
and it could be other things, that may not burn, like a watershed. I mean, the watershed might burn, but it'll affect the water quality. So
okay, or that are affected by.
And in fact, I think watershed should be one of your values at risk, because that obviously is an important deal around here these days.
Yeah.
There's also air quality, which is related to smoke. And, that's something that after the fire is gone, hopefully after a while, the smoke will subside and so on. But I'm talking in Montana right now. I just had to clear my throat. The smoke is like, you can chew it here. It's just really bad.
And really far away from the fire too, potentially.
Yeah.
And
definitely.
Right. And then of course we have the cultural assets, the infrastructure assets like houses and civil infrastructure. Yeah. Okay.
Human rights?
Yes.
Like agriculture and products as well.
Oh yeah, and also animals, right?
Yeah.
Especially wild animals.
Biodiversity over there.
Right.
Yeah.
And the trees and other plants.
I think quality of life is a good one as well.
Okay, this is really interesting because this again connects to a lot of those UN ontologies that are dealing with these as parts of the SDGs. So I know, so the SDG engagement, Sustainable Development Goal, that's the signatory nations are kind of trying to normalize their measures of these various things that are very slippery, like human well-being. Like good luck defining that. Or vulnerability, etc. But so that's okay. This is the story. This is good. We have a bunch of values at risk. Let's grab them. But there's also, so this vulnerability is kind of, all of these values at risk have a certain kind of vulnerability, right? So, like when we're dealing with UN semantics and we try to define vulnerability, the economists, etc., are heavily involved in that because vulnerability and risk is associated with, let's say, the monetary exposure, or it's quantified with money, but not just money. But it's like the exposure. Wow. So the idea is this trinity of vulnerability, risk, and exposure. Are you thinking along the same lines, or is it a bit different in your world?
When I think of, there are a lot of different ways to think about vulnerable populations. Like one of the things that happens on wildfires, or people tend to think about is oh well, we need to protect the most valuable property. And when I look at that, I always think about, well, the people that most need protection from fires are people that can't recover from the loss of their property. So the vulnerable population is really the uninsured or the underinsured populations, which are typically the people that have the most to lose, that don't have a second home, or don't live on a beautiful house up on the hills. That if they lose their property, they lose their livelihood, or they lose their businesses and they lose their livelihood because they can't afford to rebuild, or they lack access to adequate fire protection because they live in a small town. Or there are lots of ways to describe vulnerable populations, or as well as like I'm going through this right now. Like I'm a sort of a vulnerable population. There's a flood occurring, you know, in front of my house and on the Poudre River, and if my bridge washes away, I lose access to my property because I can't get insurance for a bridge. You know, so there are different ways to look at that, you know, that idea. Or if I'm a rancher and all my grass burns up, and this is one of the problems that we see with people from different parts of the country coming to fight fires, is they don't understand the local, you know, values and you know, agricultural land. Even though it just looks like, oh, it's just grass, it'll grow back. If it burns up, you can't feed your cows, you might suffer an economic disaster from that.
Also, probably something like museums, unrecoverable stuff.
Yeah, things that, you know, that are irreplaceable.
Yes, right.
If that's good, is that the replaceability of things or the irreplaceability, etc. That's really interesting. So these axes of vulnerability, and I like that note there. So this as you said, this understanding of the intervention force doesn't always align, well, doesn't always account for local vulnerability structures.
Yeah, and like, you know, where I have my cabin, my land cost me $120,000, and the value of it is in its view and its, you know, quality. My cabin cost me $30,000 to burn or to build. My cabin's insured, but the land around it, the values around it are not insurable. They don't insure things like that. So
you say they're not insured. It's like you can't find an insurance product to map it, or match it, or it's too expensive to insure. It doesn't make sense to insure.
I think it's probably a little of both, but I can't find anybody to insure like the view from my cabin. You know, that's why I wanted to move it.
And I'm just going to jump in real quick here and let everybody know I'll be closing the other breakout room in the next 60 seconds. So we'll have the other folks trickling back in.
And I note that Zoom now has the ability to save the transcription, a live transcript of all the things that are being said here.
That's scary. That's scary stuff.
And it may be scary, but I'm doing it because this was very rapid. And I think we probably have not captured even half of the information we could have.
I would guess we could spend weeks on this and still not capture everything.
May be true, but still.
I mean, that's why it took 2 years for the cryo hackathon, right?
Our
Yes.
AI system will translate all of the recording into a model.
I love it.
We should ask the other group, since they're working on machine learning, to do that for us.
Perhaps ask you to come meet with us, the Semantic Harmonization group, if you had time, perhaps, to continue this.
I mean, we'll be working on things like this, and I think, you know, once we have some of it, it would be nice to have some guests from the wildfire world to come in and check on the stuff and see if it's usable and how it can be used in some of these products that you're talking about. Indeed, for GIS, it's just like adding these annotations once we create them to the various entities we've talked about, and then you can cross-map systems. So it'd be really great to have that. I mean, this has been a very enriching experience already to understand a little bit of the landscape, and this gives us that anchor point to start, you know, things to ask, especially when it comes to the operational terminology, things like this, you know, the rollout, the spotting, etc. That's stuff that's like not on our radar, and it's hard to find in generic resources and references. So thanks a lot for that. That's really cool.
Pierre, I find it fascinating that you can do this and talk at the same time, especially after giving your COVID shot.
Yeah, you know, things are kicking in. I'm not. This could be a dream from my perspective, but I'm just rolling with it. You know.
Maybe you should get multiple COVID shots, Pierre.
Just watching your brain function is pretty fascinating.
I'm ready for a third one.
I've sat through this a couple of times. It is amazing what Pierre does. So we're all back together, and we have a few minutes for each of the group to just do a short report on what they've done. Should we start with the group that remain in the main room?
Yes, I vote for that.
So who would like to give a quick summary of what happened?
Pierre, you can do it, or I could do it if you don't want to.
I can start, and then you can fill it in. So picking up on what we spotted in the discussion previously, the presentations, the kinds of terminology that was used, we just took a dive into that. What's behind those words? How do they relate to each other? To start a little bit of what we will continue with in the Semantic Harmonization Cluster, translating that to a machine-readable form. Generically, so that all of these different semantic resources, the ontologies that join us, the thesauri that join us, etc., can have an expert-guided baseline to start their work. So we talked about it. Dave and others contributed to discussing what they mean by the abstractions like polygons, what they map to in the real world. And we generated a sort of ontological mind map, which is going to be our anchor. So again, relating the polygons and spatial entities and the kinds of polygons, we call them Dave's planning polygons for the moment, the kinds of polygons to what they map to. So the kind of word that we use operationally, features of interest. Again, different communities will have different features of interest. So we're trying to map what this community means and what their roles are. Are they fire breaks? Are they fuel sources? What processes are they involved in? The spread of fire, how are they involved in that by regulation? The interventions, and that's where we saw some really interesting things like with the keyword wildfire behavior, which was very interesting to me. What is that? And then we get to this lingo, this expert terminology, which would be hard to spot elsewhere. And that's really, really important for then getting into the ontology. So text mining agents, ML agents will be able to pick up stuff inside documents or spoken over the radio using text-to-speech as we're doing now that I learned over here. And then we talked about some of those threats, the kinds of fuel types that will be definitely something to expand on, and the kinds of classification of fuels. There was a note here during that there's a classification. There are 13 standard fuel sources used in the US. And as I said, that's the sort of thing that sets an ontologist's heart aflutter, because as soon as you have a standard classification, you can do great knowledge representation. Then we talked a little bit about values at risk, what they are, how they relate to vulnerability, risk, how that relates to the probability of being impacted, the resilience and robustness of the things that are impacted, how quickly can they recover, are there insurance products? So all of that these are all stubs that we can develop in our semantic harmonization work. And then we came across very interesting things like the primary causes of wildfire, which includes campfires left by transient populations, which is a vulnerable population linking back to vulnerability. And that's fascinating because, again, interventions aren't always about putting out fires. They're sometimes about amending social issues that connect to earth science issues. And that's a really great case for SDG monitoring and advising policy. So that's a general overview of what we were up to. And this will be a nucleation point for some of our ontology work. Ruth, over to you.
And I don't have anything to add to that.
Wow,
but I will note that we captured a lot of terms that didn't quite get onto the map in the chat. So we'll save that. And I have a companion CMAP that I was working on while Pierre was doing his. And we're going to keep the transcript here because there's a lot of terms that can be mined out of it.
Although I do think Pierre captured a lot of it that was happening in the text.
Yes. Yes, I agree with that. I'm very impressed as well.
Yeah, definitely second Rama's chat comment. Very impressive work, indeed. Brian, can you do a quick summary of the other group?
Sure, I will share my screen.
Okay.
Window. Oh, here we go. Okay, you should see the window that I'm sharing. So what we did was we focused in on one of the needs identified through Everett's talk, and the need here is captured in table 2, The need was from table 1, which, if you recall, table 1 is a combination of concepts and needs. But the need identified by the entry T1.11, the need that Everett expressed was improved interoperability of sensor systems and sensor fusion from the data fusion from multiple sensor systems, so that when the fire incident manager is looking at a scene, the fire incident manager can determine whether there is a false positive for a fire warning or is it really a fire. So what we're talking about here is the ability to fuse data from multiple sources of data for assessment of the current situation. And where we moved on from that is we talked about the utility of mobile platforms like sensor packages that can be moved more or less as a unit, whether those sensor packages are deployed opportunistically or actually deployed long-term. When I say opportunistically, it could be in advance of a fire. If this plot of land is prone to fire for this season, you could proactively and prior to any fire happening, you could deploy those there. But a member of our group also suggested, very interestingly, that you could deploy these sensor packages ahead of places where there are prescribed burns. Now, why do that? The reason for doing that is you want to collect correlations of things like soil moisture, canopy height, the health of your canopy, things like evapotranspiration rates and that kind of thing from your environment. And then you let a prescribed fire burn through, and then you put back, you replace your mobile deployable packages back in the place where you had originally before the fire. And so knowing the correlations before and after fire for prescribed burns, what you can do then is very important. What you can do then is you have correlations between these parameters. Now, given something called the burn area reflectance classification, which is generated from satellite imagery. Now, the bug essentially detects the amount of reflectance from your satellite imagery to estimate the amount of area burned. However, in the real world, the bug maps are not totally reliable. They give you an indication of the burn severity, but in order to estimate the real burn severity, the ground crews actually have to visit the burned areas and do ground surveys. Now, so the rationale behind mobile deployable packages, right, put in prescribed burn areas is so that once you establish the before and after burn parameters, you can apply the relationship to, for example, bug maps which are acquired via remote sensing to give you a better estimate of what is on the ground, right? As opposed to, in addition to sending investigators out to the field to actually estimate the burn severity. Now, that capability of estimating burn severity is very important for these things called BAER teams, BAER, which is the Burn Area Emergency Response Teams. These are the guys that are deployed to recommend close to the end of a fire. The BAER teams have to recommend, based on the burn severity, what the authorities should do in terms of mitigation measures to prevent things like landslides from affecting towns that are downstream of the wildfire. So the BAER teams have a very important role. Their actions, which are partially based on burn severity, will save lives. And where I'm getting back to and how it relates back to this requirement, that this need that you're looking at on the screen, is that if you are able to better estimate the relationships between the variables measured from multiple sensing systems, including in situ and remotely sensed data, you are able to better deliver information that the BAER teams can use to save lives and values at risk. So that's what we discussed in a nutshell.
Brian. Of course, we will be continuing working on these tables, filling them out, and working with Everett just to fill out the tables. Couple things. We have 5 more minutes, so we're going to wrap up soon. Just want to mention that we've been in contact with the agency, USDA agency, the National Institute of Food and Agriculture, and they have a funding program for conferences. So we've been encouraged to organize one on the theme of wildfires. So that's something that it's still very, very prospective, and we're exploring the possibility how this workshop here and the results from which can be used as a springboard to organize a follow-up workshop either later this year or early next year. So as we get more into that in discussing this possibility with NIFA, we will inform everyone and see if anybody will want to also get involved. Anything else, Brian, that you have in mind, or any of the people in semantic harmonization that you want to bring up in the last few minutes?
Hey, Bill and Brian, I do have my ranking from that table, which I can share with you afterward.
Okay, great. Terrific, thank you.
And so one last parting short word is parting words are as long as you've registered your email in the notes, there will be some follow-up because we need to clean up some of the documents and that kind of thing. And so you will get a notification not before too long on what we have done to clean up and potential next steps.
I'm wondering, our email address, will there be like a table of email addresses if we want to do any follow-up with the folks that were on the call here?
Yeah, I think that should be, yeah, I mean, we have the email, so that definitely could be made available.
Okay.
Yeah.
So this is Gary. I would just follow up something in the chat from Pierre, that the common operating picture model, which is more discussed in the second breakout than the first, might represent exactly an analogous opportunity to develop a conceptual map of that, and then maybe integrate it a little bit with what was done on the Polygon effort. That would be an interesting follow-up.
Indeed, because the common operating picture concept it comes across for multiple users, like for Dave, like for example, for Dave Zader, who needs to look at things from a mitigation strategic planning perspective to pull in various data into a common operating picture, or I think more critically for incidents command, when you're in the midst of a fire, then the whole concept of common operating picture changes a little bit, but it's based, I think, on some of the common concepts that you would find in mitigation planning. But I think the COP, common operating picture, for incidents, reaction, and planning may differ a bit, but that's where the COP also ties into software like GeoCollaborate and a lot of other, or in Dave Zader's case, Dave, I know you're interested in the DoD's ATAK platform as the way to look at the common operating picture.
Yeah, I think this common operating picture is also where the two types of polygons, Dave's and Everett's, and can come together, as Ruth's earlier mentioned. I think that would be really interesting.
Yeah, the Virus project in Southern California is a great example of blending multiple types of technology together in one common operating picture to look at fire progression, where the actual fire or a fire forecast, where the actual fire perimeter is, where resources are. And then this is, the kind of the fourth leg is trying to, bring in pre-fire planning and being able to view that data in that same platform. And I think that same platform needs to be, the same platform used for planning, the same, or at least interoperable with the same platforms that use for planning and tactical.
So one thing before we dismiss everybody, we're right on 1:30, but Bill, I'm going to suggest something kind of real time, which we didn't discuss before. But if it is in the interest of folks around here to gather and to say what you want to do next, because there's interest, of course, from Envirosensing Cluster, and of course Dave Jones representing Disasters Lifecycle has also an interest in all that we're discussing. Naturally, semantic harmonization, that's an interest too. And from both Dave, Zeta, and Everett's perspective, I think there'll be things we can do that will be useful to their communities. And so in the interest of maybe following on this conversation, since we have all your emails, I might email out to suggest a time where we can get together within the span of this ESET meeting, because we can ask for like a little breakout room kind of thingy. What do you think, Bill?
Like an unconference.
Yeah, sorry for springing this on anybody without asking.
Well, yeah, I mean, we can find a time, but it's just, whether everybody's availability in the next couple of days. So, I mean, maybe we can just send out the email to everybody and see whether we get enough people to hold it on conference.
Sure.
Yeah, so let's do that. Sure.
Okay, so folks on the call, Bill and I will coordinate with ESET to try to figure something out.
Yeah. Okay, so we are 2 minutes past, so just want to thank the speakers, Everett, Dave, and Pierre, for really, very interesting, fascinating talks. And of course, everybody for participating in this workshop and the breakouts. Hope to continue the discussion afterwards and the collaborations amongst all the clusters and with external organizations as well. Thank you, everybody. Have a